Okay, imagine this for a second. A perfect virtual copy of you living inside a computer. A copy that could test out new medicines so you don't have to, or figure out the perfect athletic form for you, or just be your avatar in the metaverse. Now, this isn't some far-off sci-fi dream. It's the very real concept of a human digital twin. And today, we're going to break down the huge challenge of how we build one of these things without totally wrecking your device's speed or, your privacy. So let's get right into it. A human digital twin, or HDT for short, is not just some static 3D model. Nope. Think of it as a living, breathing virtual version of you. It's constantly being updated, pulling in real-time data from everywhere, from your smartwatch, your health records, maybe even your social media, all to create a replica that simulates not just your body, but your psychological state, right now. And the potential here? It is absolutely staggering. I mean, we are talking about developing personalized cancer therapies on your digital twin before ever trying them on you, or optimizing a marathon runner's entire strategy by simulating the race 100 times. Or creating a metaverse where your avatar actually reacts and feels just like you would. This could completely change everything, even education, with learning plans that are truly customized to each student. But, and you knew there was a but, creating this perfect replica brings us to a massive, massive technical hurdle. This is really the core problem we have to solve before any of that cool stuff can happen. Let's call it the replication dilemma. The easiest way to wrap your head around this is to think about loading a video game. To get your HDT ready for a virtual experience, the system has to materialize it, which is basically like loading the game world. But get this, generating just a cardiac digital twin can take 4 hours. So if you try to do that on the fly, you get insane lag. But if you do it all beforehand, well, that's like downloading a gigantic game you might not even end up playing. So we're kind of caught between a rock and a hard place. This slide really lays out the two pretty bad options we have right now. On one hand, we can build your twin on the fly. That saves resources, but it leads to a super laggy, frustrating experience for you. On the other hand, we could just preload everything. Sure, it's fast, but it's a colossal waste of computing power, and this is the big one, it's a massive privacy risk. All your most sensitive data is just sitting there, totally exposed. Neither one is a great choice. So how do you get that lightning-fast speed without throwing efficiency and privacy out the window? Well, researchers have come up with a really clever strategy to solve this exact problem. It's called HDD ViewMat, and it's all about working smarter, not harder. The main idea behind it is actually brilliantly simple. Instead of this all-or-nothing choice, generating everything or generating on demand, the system gets smart. It actually predicts what you're most likely to do next in the virtual world, and then it preloads only the specific parts of your digital twin that you'll probably need just moments before you need them. And this whole prediction thing gets boiled down to one single number, the execution chance, or EC. So for every possible thing you might do next, the system calculates a score. If the score is high, it's basically shouting, hey, get this part of the twin ready right now. If the score is low, it says, nah, don't waste the energy on this one. But how in the world does it calculate that score? Well, one of the key ingredients is something called a privacy level agreement, or PLA. The best way to think about this is as your personal privacy comfort score. The system literally reads the service provider's privacy policy, what they plan to do with your data, and compares it to the preferences you've set. A high score means you're probably going to be okay with their terms. And this is where it gets really, really cool. The system combines two things: the cold, hard probability that you'll do a certain task, and your personal feelings about the privacy involved. So if an action is super likely and you're comfortable with the privacy policy, boom, that's a green light to preload. It's this beautiful marriage of pure math and personal choice. Okay, so that system works beautifully for one person. But what happens when you're not alone in the virtual world, right? Things get a whole lot more complicated when you throw a crowd into the mix. The research paper uses a fantastic example: a virtual classroom in the metaverse. Just picture it. You've got, say, dozens of students, and every single one has their own unique ideas about privacy. And on top of that, you might have multiple companies running the class, one for the virtual lab, another for the lecture hall, and each of them has its own data policies. It's a total mess of conflicting rules. So, this brings us to the million-dollar question. How on earth do you find one single privacy policy for that class activity that actually works for everybody? One that doesn't make the students feel exposed, but still gives the providers the data they need to make the thing run. I mean, it seems basically impossible, right? Well, the solution is something like digital diplomacy. The system has this little component inside it called a policy negotiator, whose whole job is to find a middle ground, a compromise that everyone can live with. And here's how it pulls it off. First, the negotiator just gathers up all the data, every single student's preferences and every provider's policy. Then it analyzes them all to find every single point of conflict. Now, the magic really happens in step 3. A super smart algorithm runs what's called an optimization problem. It tries to minimize the privacy cost to the users while maximizing the data gain for the providers. And finally, out of all that, it generates one single, balanced, representative policy just for that task. The researchers themselves put it perfectly. The entire goal is to find, and I quote, a compromise between the requirements imposed by service providers and the preferences expressed by users. See, it's not about one side winning. It's about finding that perfect sweet spot where the virtual service can run without a hitch and without making people feel like their privacy was thrown out the window. So all of this sounds incredibly smart in theory. But the real question is, does it actually work in the real world? Well, the researchers put it to the test, and let's just say the results are pretty impressive. Yeah, the results are just staggering. Take a look at this chart. It shows the difference between the old, clunky way and this new, predictive way. We are talking about a massive, massive drop in how long you have to wait. This isn't just a tiny improvement, it's the difference between a frustrating, laggy experience and one that feels totally seamless and immersive. And all of this brings us to a final, much bigger question. This research gives us a really elegant technical solution for that balancing act between privacy and performance. But as these digital twins become more common, more integrated into our daily lives, it brings up a really fundamental issue. Who gets to write the rules for our virtual selves? Is it us? Is it the companies providing the service? Or is it a smart algorithm finding a compromise somewhere in the middle? That's something we're all going to have to think about.